Hello, hello. Welcome back to all the students. I am Captain Ray Sanjeev. Welcome to online classes from Department of Chemistry, Government Degree College, Peddapalli. In the last class, we have covered uh, preparations of alcohols and phenols. Some of the preparations of phenols covered in the last class. Today we are going to discuss about another preparation of phenol and the remaining chemical properties of this particular alcohols. Today, uh, before going to that chemical property, the last preparation of phenol. Uh, Phenol is prepared industrially via a multi-step process. It is a multi-step process involving the formation and oxidation of cumene. Here please observe, this is the starting material, benzene we are using. Benzene on reaction with the olefin, alkene, propylene in presence of phosphoric acid. Here this propylene alkene chain attached on the benzene ring, it converted as in presence of this particular um, phosphoric acid, it converted as cumene. Cumene, is it clear? Cumene on oxidation it converted as cumene hydroperoxide. Cumene, this is the peroxide functional group attached to this chain. Cumene hydroperoxide. Cumene hydroperoxide um, on acidic hydrolysis. Acidic hydrolysis, it gives phenol, the final compound. We are getting phenol. It is the byproduct acetone. Acetone is the byproduct. This is the uh, way of preparation method of phenol. Phenol. Is it clear? Now let us go to chemical properties. Chemical properties of in the previous lecture, nomenclature of alcohols and phenols covered, physical properties of alcohols and hydrogen bonding in alcohols, acidity of alcohols and phenols covered in the last topic. Now let us go to actual chemical properties of this particular alcohols. Here, tertiary alcohol. Tertiary alcohol. Tertiary alcohols undergoes a substitution reaction when treated with the hydrogen halide. Here, that particular hydroxy group substituted with the halogen HX we are using. Breakage of this HX, this halogen replaced this particular hydroxy group. Okay, X. Okay, OH and H, it converted as water molecule. This is about tertiary alcohols. Tertiary alcohol generally undergoes substitution reaction with this particular halogen. Is it clear? This is a SN1 reaction with the alcohols. We'll discuss in the reaction mechanism part. This is the actual reaction mechanism part for this substitution reaction. Here, uh, tertiary alcohol. Tertiary alcohol is the starting material. Tertiary alcohol. In the first stage, proton transfer stage. Proton transfer from HX. Here, HBr we are using. That particular hydrogen transferred to hydroxy group. Now it converted as protonated alcohol. It is an intermediate protonated alcohol. It is a unstable compound. Protonated alcohol. From this immediately loss of leaving group. Here leaving group water molecule. Loss of leaving group. Loss of leaving group. Second step. Here it is not step. It is actually unstable compound. Unstable compound from this unstable protonated alcohol immediately loss of water molecule. Here loss of leaving group, that particular water molecule. It forms carbon cation. Carbocation. This carbon, center of the carbon gets positive. It is called carbocation. This particular carbocation is formed as a intermediate. For this intermediate on carbocation carbon plus attacking of nucleophile. This particular Br minus nucleophile attacks on carbon positive. Okay, here to form a sigma bond in between carbon and Br. Is it clear? This particular OH hydroxy group replaced by halogen. This is the SN1 mechanism. SN1 mechanism. Is it clear? SN1 mechanism. In the first step, just a proton transfer step to form an unstable protonated compound. Then it converted as stable carbocation. That particular stable carbocation in the second step attacking of nucleophile will get a final compound alkyl halide. Alkyl halide compound. Okay, this single step reaction, this is the clear mechanism part of that particular SN1 mechanism. It reaction proceeds SN1 mechanism. Is it clear, all of you? Okay. Now let us go to SN2 reaction with the alcohols. SN2 reactions. In SN2 reaction, it is a single step reaction. There is no two steps. In what way? We'll observe clearly. Primary alcohols. In SN1 mechanism, generally tertiary alcohols are involving as a starting material. Here primary alcohols will react with the HBr, hydrogen bromide, via an SN2 process, SN2 mechanism. How is it? We will discuss. Please concentrate. This is the primary alcohol. Normal chain bonds with the hydroxy group, primary alcohol. The first step is same, proton transfer step. Proton, that HX from HX, hydrogen H plus ion, H plus ion transfer to hydroxy group side. It converted as protonated alcohol. That particular protonated alcohol, it is a unstable alcohol. Immediately the nucleophile, Br minus nucleophile attacks on this carbon, this terminal carbon. Immediately loss of water molecule. Here nucleophile attacking and loss of leaving group in the same step. In the same step it proceeds in the same step because it is called SN2 mechanism. In the SN1, in the earlier reaction SN1 mechanism, we observed first loss of leaving group. It forms a carbocation stable cation. But here that step is not proceeds. It is a direct process, direct nucleophile attacking. At the same time, loss of leaving group, this particular water molecule loses from the reaction. Here water molecules removed from the reaction and alkyl halide to form alkyl halide. Is it clear? This is the SN2 mechanism. In SN2 mechanism, what we observed in a single step, nucleophile attacking and at the same time um, loss of leaving group present in the same step. Okay, is it clear all of you? With the SN2 mechanism. Now let us go to another very interesting reaction. Here we are using catalyst, different catalyst in presence of different catalyst. Uh, that particular catalyst, in presence of that catalyst, for example, is acid type of catalyst. That leaving group is very activated, easily removes from the intermediate. We will observe in the mechanism part. Please concentrate this particular reaction with the special catalysts, in presence of special catalysts. Here this reaction works well for HBr but does not work well for HCl. Okay, to replace the hydroxyl group with the chloride, ZnCl2 zinc chloride is used as a catalyst. Here hydrox primary alcohol on reaction with the HCl in presence of this particular catalyst, zinc chloride. Here hydroxy group replaced by halogen. We are getting alkyl halide. This catalyst zinc chloride is a Lewis acid. Zinc chloride is a Lewis acid that converts the hydroxyl group into better leaving group. Better leaving group. Here please observe, this is the primary alcohol. In the first step on reaction with the catalyst zinc chloride, nucleophil, here nucleophilic attack on Lewis acid. Lewis acid. Here reaction with the Lewis acid to form an intermediate. This particular intermediate, this Lewis acid uh, attacking on hydroxyl group, it is a this chain, it is a better leaving group, acted as a better leaving group. Okay, when compared with the last reaction. Last reaction, here water molecule, protonated alcohol. Compare with this protonated alcohol, the oxygen attached with the ZnCl2, this particular bulky group is a better leaving group. Now attacking of nucleophile, Cl minus nucleophile, it is also proceeds SN2 mechanism. It is also proceeds SN2 mechanism. Here leaving group, and at the same time attacking of nucleophile at a terminal carbon. Attacking of nucleophile, at the same time loss of leaving group in the same step, because it is called as SN2 process. Okay, loss of leaving group, we will get a alkyl halide. We'll get a alkyl halide. This is the different from last reaction, because here we are using extra zinc chloride catalyst. It is a Lewis base, acted as a Lewis base. That particular Lewis base on reaction with the hydroxyl group, it converted as a better leaving group immediately after attacking of nucleophile. That loss of leaving group takes place very easily. It loses very fastly from the intermediate. We'll get the product very fastly. Is it clear? Is it clear? In presence of zinc chloride catalyst, the reaction proceeds. Now let us go to another very interesting reaction. An alcohol can be converted into tosylate followed by nucleophilic attack. Here also leaving group may be different. Here alcohol, secondary alcohol, bad leaving group. Here bad leaving group on reaction with the tosyl chloride in presence of pyridine. In presence of pyridine tosyl chloride. Here hydrogen atom replaced by this particular tosyl bulky group. In presence of this tosylate, it acted as a ester. It's just like a ester, tosylate compound. It is a good leaving group. It converts as a good leaving group. In this case, OH is a bad leaving group. After replacement of this tosyl, converts as a tosylate, huh? It acted as a good leaving group. Then same SN2 mechanism, it proceeds SN2 mechanism. That particular X minus nucleophile, X minus nucleophile attacks on this particular carbon, immediately loss of leaving group. Immediately loss of leaving group. Here attacks X halogen, alkyl halide. It forms alkyl halide. But the configuration may be different. Here OH and this particular attacking of X configuration may be different. We will discuss that configurations. Here using tosyl chloride and pyridine. Tosyl chloride in presence of pyridine. The hydroxyl group here, hydroxyl group is converted into tosylate group as an intermediate. Just now we observed. This is the tosylate intermediate. Hydroxyl group on reaction with the tosyl chloride in presence of pyridine, it converted as tosylate intermediate. That tosylate group, an excellent leaving group, which is uh, susceptible to an SN2 process. That SN2 process, it proceeds in a single step when attacking of nucleophile, at the same time a loss of leaving group. This SN2 process proceeds very perfectly in presence of this particular excellent leaving group of tosylate. Okay. The configuration, how the configuration changes, we'll discuss. The configuration of chirality center, this center, chirality center is not inverted during the formation of tosylate, but it is inverted during the SN2 process. Here, from starting compound on reaction with the tosyl chloride and pyridine, there is no change, there is not inverted in the formation of tosylate, but there is a inversion process from tosylate to attacking of nucleophile, that is SN2 process. There is a inversion. Here OH configuration is R configuration, but attacking of bromine, it is a below the plane S configuration. S configuration. Attacking of bromine is a inversion configuration. Is it clear? Uh, that starting compound alcohol on reaction with the tosyl chloride and pyridine to forms tosylate uh, functional group. It is a excellent leaving group, but the formation of tosylate, there is not inverted, not inverted as it is, but there is a change. There is a change in attacking of nucleophile. Attacking of nucleophile, the inversion configuration is formed, that is S configuration is the product. We are using R configuration starting material to forms S configuration product. Is it clear? Is it clear all of you? Okay. Now let us go to another type of catalyst we are using. Generally, primary and secondary alcohols reacts with the thionyl chloride, SOCl2, thionyl chloride, or PBr3, phosphorus tribromide via an SN2 process. Same, in the single step process, the reaction proceeds. How is it? We'll discuss. Here, primary alcohol we are using as a starting compound. Primary alcohol on reaction with the thionyl chloride in presence of pyridine. Thionyl chloride in presence of pyridine. To forms alkyl halide. To forms alkyl halide chloride. Alkyl chloride. Is it clear? One, two, three. Propyl chloride. Okay. The same starting material, primary alcohol, on reaction with the phosphorus tribromide. Phosphorus tribromide to forms propyl bromide alkyl halide. These two reactions proceeds via an SN2 mechanism. SN2 mechanism. Okay. Uh, Now we'll observe actual mechanism part. This is the actual mechanism part. Primary alcohols on reaction with the thionyl chloride in presence of pyridine. Here, same starting material primary alcohol. It is a bad leaving group. Bad leaving group OH function group. Hmm? After attacking of after on reaction with the thionyl chloride, it returns good leaving group. Here it returns good leaving group. But here first this is the single step reaction. This is the mechanism part. In single step reaction already we discussed this primary alcohols on reaction with the thionyl chloride in presence of pyridine converted as alkyl halide propyl chloride and sulfur dioxide chloride ion. Okay, this is a single step reaction. How the reaction proceeds will observe clearly in the mechanism part. Here please observe primary alcohol. It is a bad leaving function group, bad leaving group. This particular primary alcohol on reaction with the thionyl chloride. This is the actual structure of thionyl chloride, SOCl2, thionyl chloride. This hydroxy functional group oxygen pair of electrons donates to sulfur atom. Here immediately that particular pi bond in between sulfur and oxygen pi bond cleavage takes place. This oxygen atom gets negative. Atom gets negative. Okay. And this particular oxygen here loss of electron because this hydroxy group oxygen is also gets positive. Here loss of electron because it gets positive charge on oxygen. Okay. Next, the negative charge. These electrons shifted to inner side. Here loss of nucleophile. Cl minus nucleophile. Okay. Loss of nucleophile. Here to form a double bond in between sulfur and oxygen. Here please observe. In between sulfur and oxygen to form a double bond. Okay. To form a double bond. Then then in presence of pyridine this reaction proceeds. Here pyridine molecule involves in the reaction in this step. Pyridine. Pyridine abstract this hydrogen cleavage of this OH bond. Okay, OH bond, and this particular oxygen gets neutralized here. Here oxygen atom actually positive charge. After breakage of this OH bond with this pyridine abstraction of hydrogen cleavage of OH bond, this particular oxygen neutralized atom neutralized. Okay, this is the this bulky group is acted as good leaving group. This bulky group SO2Cl bulky group acted as good leaving group when compared with this first leaving group. This is the bad leaving group. Bad means slow. From this, when attack of nucleophile on this carbon, uh, loss of leaving group, it takes time. Okay, but in presence of this type of leaving group, attack of nucleophile, immediately loss of this particular leaving group. Here in the last step, please observe attacking of nucleophile, Cl minus nucleophile attacking on this carbon. When that particular leaving group attached to carbon, here nucleophile attacks on that particular carbon. Here cleavage of CO bond. CO bond. Here it turns SO2, loss of Cl minus nucleophile. Here loss of Cl minus nucleophile. It turns SO2 molecule. SO2 molecule. This compound is the major product alkyl halide. Three carbon containing halide. 1, 2, 3. Propyl chloride. Propyl chloride is formed, is produced from this reaction. From this reaction, this is the clear cut information, clear cut mechanism part. First, we observed in this reaction the bad leaving group of this particular hydroxyl group. First, in presence of thionyl chloride, it turns as a good leaving group. Good leaving group. After that, in presence of that particular good leaving group, attacking of nucleophile and a loss of leaving group, in the same step, in the same step to forms alkyl halides, because this reaction proceeds in SN2 mechanism. SN2 mechanism. Is it clear? Is it clear, all of you? Now let us go to another PBr3 mechanism. Another reagent we are using PBr3, phosphorus tribromide. In presence of that particular catalyst, how the reaction proceeds, we'll discuss now. Here, please observe, please concentrate, all the students. These are all the mechanisms are very interesting, very interesting. Please concentrate each and every step in SN1 mechanism or SN2 mechanism, which type of reaction proceeds. Please concentrate on these steps. The reaction mechanism for PBr3, phosphorus tribromide, has similar characteristics, including conversion of the hydroxyl group into a better leaving group followed by nucleophilic attack. This PBr3 mechanism, it is very similar characteristics when compared with the thionyl chloride reaction. Okay, with the thionyl chloride, earlier we discussed the same reaction proceeds with the PBr3. The same similar characteristics in this reaction and conversion of hydroxyl group, that bad leaving group is converted into good leaving group, then attacking of nucleophile in the process is similar with the thionyl chloride. Even though we'll discuss once again with this PBr3. Here, please observe, primary alcohols are involving in this reaction. Primary alcohol, propyl alcohol. Alcohol, this type of structure, this is called as bad leaving group. Bad leaving group. In the first case, first this bad leaving group is converts as good leaving group in presence of phosphorus tribromide. Here, this particular hydroxyl group, pair of electrons, lone pair of electron bonds with the phosphorus, sharing of these electrons with the phosphorus. In that case, this particular oxygen of hydroxy group gets positive. Here loss of electron because this oxygen gets positive. Is it clear? The remaining here loss of immediately loss of Br minus. Br minus from this step. Then the intermediate, this formation of this particular intermediate, it acted as a good leaving group. This particular bulky group, here we are showing a separate box. This is a bulky group, good leaving group. Okay, in presence of this type of good leaving group, here attacking of nucleophile, attacking of nucleophile Br minus nucleophile on the same carbon, immediately loss of leaving group, immediately loss of leaving group in the same step, because this step, this reaction proceeds via an SN2 process, an SN2 mechanism. Is it clear? An SN2 mechanism. Br minus nucleophile attacks on that particular carbon, immediately loss of leaving group. Loss of leaving group. Here phosphorus Br2 minus and another minus OH minus is bonded with the phosphorus. Here the major product is alkyl halide. Alkyl halide is produced from this reaction. Is it clear, all of you? This is about PBr3, phosphorus tribromide. When we use phosphorus tribromide as a catalyst, here thionyl chloride. This is about starting reaction. Primary and secondary alcohols. We can write with the secondary alcohols. We can react with the secondary alcohols as a starting material, starting compound. Primary and secondary alcohols generally react with this thionyl chloride in presence of pyridine or phosphorus tribromide. Tribromide. These two reactions are very similar. Similar. What happened in these two reactions? That particular primary alcohol or secondary alcohol, these two alcohols contains a bad leaving group, contains a bad leaving group, this particular hydroxyl group, bad leaving group. In the first case, in presence of this particular thionyl chloride or phosphorus tribromide, First, we converts this particular bad living group to good living group. After that, attacking of nucleophile, and in the same step here, loss of that good living group to forms alkyl halides as a major product in this reaction. This is the single step reaction. For this reaction, we discussed first thionyl chloride mechanism part and phosphorus tribromide mechanism part we discussed clearly. Please concentrate all these reactions, all the students. This is about today's lecture. Tomorrow we will meet at same time. Please practice all these reactions. Thank you one and all.